We were discussing the configuration of transistors, and in the last class we have seen common base configuration, which means the base of a transistor is common to both the collector and emitter. So today we will discuss the other configurations and how we can use the transistor as an amplifier and as a switch. So in common base, you have seen that this is the input. Input is between the emitter and base, and output is taken across the collector and base. And this is a formula which is applicable for all configuration, that the emitter current is equal to base current plus collector current. Also, remember this formula, the current amplification factor is alpha is equal to IC by IE, where IC is the collector current and IE is the emitter current, which is the output and the input for a common base configuration. So we saw this yesterday. Let us see how we can connect the transistor in common collector configuration, which is also called CC configuration. Now look at this figure. Tell me what kind of a transistor is this? Is it a NPN or a PNP transistor? You remember how to identify a transistor. So looking here, tell me. What kind of transistor? PNP or NPN?
PNP.
PNP. Why? Because the arrow mark always points from P to N. So this should be P, this N, and this P. So it's a PNP transistor. This is the emitter, this is the base, and this is the collector. Now, as you can see here in the configuration, the collector is common between emitter and base. Here you can see this is the collector, which is connected both to the base and to the emitter. So collector is common. And in CC configuration, that is common collector configuration, the input signal is connected between the emitter and base and the collector. The input should be between the collector and base, right? So there is a typing mistake here. So here you can see that the input signal is given between the base and the collector, and the output is taken across the collector and the emitter. This is how the common collector configuration is. And we don't use the common collector configuration for amplification purpose or for switching. We use this as a emitter follower, because the output, you can see it's emitter by collector, right? So this configuration is not used either as an amplifier or as a switch. So we will see the most important kind of configuration, that is the common emitter configuration. This common emitter configuration is used both as an amplifier and as a switch. Now, can you tell me what kind of a transistor is this? Can you tell me what kind of transistor? NPN or PNP?
NPN.
It's NPN because the arrow mark is from P to N. So this is P to N. So this is NPN. So this is a NPN transistor. And this one is the emitter, which is connected in common to the base and also to the collector. You need to learn this figure. You will have to draw and explain how a common emitter configuration can be used as an amplifier. So here you have the common emitter configuration. See how the biasing is. I told you that always the emitter base junction will be forward bias. Let us check. So this is NPN, right? So the P here is connected to the positive of the battery, and N here is connected to the negative of the battery. So this connection is right. How the positive is here? Because it is forward bias at the base emitter junction. So this is forward bias. Now, how to find the biasing here? We know that emitter current is equal to base current plus collector current, right? So the emitter current should enters this junction. So base current and the collector current will leave the junction. We always know that the current is directed from the positive and goes to the negative. So check here, the emitter current comes out like this. So the base current and collector current should go like this. So this should be the direction of current. So this should be positive and this should be negative. That is how we decide how to connect the cells or the battery here. Is that clear how to draw this? How to draw the circuit?
Yes.
So these are the points to be noted. Emitter base junction should be forward bias and the emitter current direction should be such that emitter current is equal to base current plus collector current. So emitter enters this junction, base and collector current leaves the junction. And we put the polarity of the cells accordingly, positive to negative. This is how the current flows. And in a common emitter configuration, the input signal, see the AC input signal is given to the base emitter junction. Here we give the input signal and we take the output across the emitter collector junction. This output resistance is sometimes called RC or it can also be called RL, the load resistance. Okay. So the output will be amplified. Amplified means the value of the maximum value of the current will be increased in both directions. Let us see how it will be amplified. So when the input is given, the output is gain. We can call it gain because there is an increase in current. Let us see how. For AC, the current gain, see the current gain is expressed by a symbol called beta. Remember, the current amplification factor was alpha, but the current gain is beta. That is equal to output current divided by input current. What is the output current here? What is the output here? What is the output current?
I
IC.
see.
IC, the collector current. What is the input current?
IB.
IB. IB is the input current. IE is common for both, right? So IB is the input current, IC is the output current. So the current gain is output divided by input. So IC by IB. For AC, we just express it as change in IC by change in IB. For a constant VCE, which means for a constant voltage between collector and emitter. This is the voltage between collector and emitter. If this is kept constant, the current gain is equal to IC by IB. So which is more, IC or IB?
IB. IC.
IC is more. We told that the emitter current, if we consider as 100%, 95% goes as the collector current and only 5% goes as the base current. So if IC is 95%, base current will be only 5%. So IB is very much less than IC. So will this be bigger than 1 or less than 1? IC by IB. This is 95%, this is 5%. So 95 divided by 5. So will this be greater than 1 or less than 1?